B plus whole to the power 2. Now I told you in the last class, for pure solids and pure liquids, the concentration do not change. Suppose if I take a zinc rod, so for zinc solid the concentration will not change because it is not in the form of ions dissolved in the water or solution. It is that solid zinc rod, so its concentration is fixed. So for pure solids and pure liquids, the concentration is taken to be 1. Is it clear? So this I will remove. I will put 1 in place of this. I will put, this is pure solid 1. Okay, so the reaction quotient is concentration of A divided by, means you just need to write the ions, concentration of B. Got it? Is it clear?
Yes, sir.
So this is Ibrahim reaction quotient. Okay, Ibrahim, in your test you have written the EMF of the cell equal to E naught anode plus E naught cathode. Okay, this is also one of the formula, but I will prefer not to use this formula because as per the convention, IUPAC convention, the reduction potentials are taken. So you should write E cathode minus E anode. Got it?
Oh, okay. Yes, sir. Yes, sir.
And both should be standard reduction potentials. I have marked it in your copy also. Okay. So just put.
Yes, sir. Yes, sir.
So I hope that you will do it. Okay. This is the reaction quotient, and you will write it. And how many electrons are being exchanged in this? Can you tell me? Aisha, Marwa, and Ibrahim, can you tell me how many electrons are being, what should I put in place of N? They will give the concentration. You are going to put this concentration 1 molar, 2 molar, whatever they are given in the question. You put them and take the logarithm. You simplify, log value will be given to you. Okay, and or I will keep telling you the log value, so don't worry about it. Okay, and what is the value of N? What is N? Marwa, can you help me out? What is N?
Is it number of electrons?
Are the electrons which are being transferred. Okay, so actually you can see here, just a second, just I think, so you can see that the I think it was deleted by some error is there. So electrons which are being transferred, so electron which are being transferred are suppose I have written like that 3A plus, okay, and 8. So 6 electrons are being transferred. Okay, just we can calculate that. So N is the value of electrons. So let's do this question. So first we have to write the Nernst equation. Ibrahim, is it clear?
Yes, sir.
So this is a cell reaction given to you, and you are asked to tell what change of ions will increase or decrease the EMF of the cell, voltage of the cell. So don't put your mind first, try to get the Nernst equation. Okay, why I'm writing the Nernst equation, why I'm not talking about the standard EMF. Standard EMF is fixed. Okay, that is not going to change because that is for 1 molar. Because this reaction is talking about the change in concentration, so I should talk about the EMF of the cell equal to E naught cell minus 0.0591. So I will write it for ease 0.06591. Okay, I'm taking it as 60. Okay. By n, and what is n for this? Is the equation balanced? First, you should check that the equation should be balanced and the electron should be same. Okay, the charges should be same. Is the equation balanced? Iron is there, iron is there. Silver is there, silver is there. +2, +1, +3, and +3. So balanced. So Aisha, can you tell me what is the value of n? Ibrahim, yeah, n is 1. Okay, because look, the silver is getting 1 electron and it is changing to Ag. And iron is +2, so it is losing 1 electron. If you lose electron, the positive charge will go up. So minus electron and plus electron. So there is exchange of 1 electron. Okay, n is 1. Is it clear, Aisha?
Yes, sir.
Okay. And reaction quotient. You will write the concentration of ions. You will not write the concentration of pure solid. Okay. So concentration of products Fe3 plus divided by Fe2 plus and Ag plus. You have ions here. Concentration of products divide each raised to the power its stoichiometric coefficient of the balanced chemical equation. The stoichiometric coefficient is 1. So concentration of product divided by concentration of reactants. Okay. This is the Nernst equation, Ibrahim. I hope this is clear. Any doubts in this up till this point? All of you?
No, sir.
Okay. So I have written the Nernst equation. So predict that which change will decrease the voltage. Okay. So if I this is the Nernst equation. Okay. And in order to get the voltage, the reaction should happen in forward direction. The reaction should happen more towards the right hand side. If it is happening, if it is forming more product, the voltage is going to be higher. Okay. So the voltage of the cell or the reaction is going to increase if you have more reactants. If you take more reactants, more product will form. The driving force for the reaction to happen is the concentration of the reactant that you must have studied in 11th also. If you don't remember, not a problem. We know, suppose if we take more reactant, they will form more products. EMF, the cell, the EMF is going to be more. Okay, this is one approach. So if you take more, both of them more, the EMF is going to be more. The voltage is going to be more because the more reaction will happen. But if you increase product, if you have more product, if the product has already formed, why reaction will happen? It will not happen. I mean, the reaction is already completed if the product is formed. Got it? So if you have more Fe3 plus, more product, the EMF is going to be less. The reaction is going to happen in less by less amount. less EMF. If you have more product, but if you have more reactant, reaction will happen more, because more reactant will react and reaction will happen more. Got it? So let me select. So which change will reduce the voltage? Increase in concentration of Fe3 plus will reduce. This will not affect. Okay. And decrease in Ag plus. Decrease in silver will also reduce the voltage, because silver is a reactant. Ag plus is a reactant. You need to take it more. If you have taken more reaction will happen, more product will. If this is less, okay, if this is less, then less EMF, less reactant, less reaction, less. Got it? So both first and second will be the answer. And this is the Nernst equation. Is it clear to everyone? Any doubts in this? Aisha, Marwa, Ibrahim?
No, sir.
Okay, clear. So now we are going to look at the relationship of this is a very important uh, diagram and formula map. Okay. Memory map for the equilibrium constant of a reaction. Standard EMF of a cell, which is equal to standard electrode potential of cathode, reduction potential of cathode, standard minus standard reduction potential of anode, and Gibbs free energy change. What is Gibbs free energy change? And what is the significance? Who is going to explain it to me? Significance of delta G. Yeah. What is delta G?
Gibbs free energy.
It tells us about the spontaneity of a chemical reaction. Right, Aisha? Whether a reaction can happen or not. Gibbs free energy decrease. It is just like a potential energy. Okay. Suppose if the Gibbs free energy change is negative, if the Gibbs free energy is decreasing, reaction will be spontaneous. So all the electrochemical cell have spontaneous reactions, and the Gibbs free energy change for their reactions is negative. As the Gibbs free energy change approaches zero, the reaction will not proceed. Reaction attains equilibrium. It will not have tendency to move in the forward direction. reaction stops, EMF is 0. In this case, E0 cell is positive, the reaction will be spontaneous. E cell, not E0 cell. If the equilibrium is attained, the reaction will loses its tendency to happen. Equilibrium has arrived. Mean the reaction can is moving in both the direction but not moving in any direction. There is no transfer of electron happening. It means that the EMF of the cell has become 0. Okay. If the Gibbs free energy is increasing during a reaction, means Gibbs free energy change is positive, EMF of the cell will be negative. And negative EMF means non-spontaneous. Non-spontaneous means the cell will not work. So what is the relationship between delta G and NFE not cell? Okay. Is this clear? So first of all, we should understand the relationship. I will get back to this slide again. The relationship between EMF of a cell and free energy change, Gibbs free energy change. First, we will try to understand this relationship. Delta G, Gibbs free energy change, the decrease in Gibbs free energy is actually, it is the amount of chemical energy which has decreased in a chemical reaction. And that decrease in chemical energy can be used to do some electrical work, used to get some voltage out of the cell. Okay, so chemical energy is being converted into electrical energy, that you know. We have discussed this in the beginning of this chapter. And this electrical energy or the voltage can do work. It can light a bulb, it can drive a motor. So electrical work which we are going to get from a cell is equal to the decrease in Gibbs free energy. It is just like the potential energy, the decrease in potential energy. We can use that decrease, whatever the amount by which it has decreased, that much work we can get. Same is here also. The decrease in chemical energy or the decrease in Gibbs free energy, okay, can help us to calculate the amount of electrical work which we can obtain from a cell. Electrical work which a cell can do is charge into voltage that is passed through cell. Charge, number of moles of electrons into F. F is charge of 1 mole of electrons. What is the value of F, Ibrahim? Aisha, Marwa, can you tell me what is the value of F?
N is the number of electrons which is
Yeah,
transferred
N.
here.
So, are you getting my point? The decrease in Gibbs free energy or the decrease in, it is just like the chemical energy that can be used to do work. That much amount of work a cell can do. The work done by the cell is charged into voltage. Charge is the number of moles of electron transferred into F is the charge of 1 mole of electron. So if n moles of electrons are transferred, the charge will be NF. The value of F is 96500 coulomb per mole. It is the charge of 1 mole of electron. And you can find out from the equation. EMF of the cell, you know. Okay. So this is the voltage and this is the charge of the electron. You can get the total electrical work which you can get from a cell. You put negative sign because the work is being done by the cell on the outer system. So the cell is losing its energy to the surroundings. So just remember this formula. The Gibbs free energy change equal to minus N F E cell. Is this clear? Gibbs free energy change decrease is equal to the electrical amount of electrical work which is done. Got it? Is that clear to everyone?
Yes.
Aisha, Marwa, is it clear?
Yes, sir.
Yes,
So,
sir.
whatever the energy has decreased, that sign is chemical energy is G, delta G. That can be used to obtain the work, electrical work. Electrical work is the charge. Charge you will find by number of moles of electron into charge of 1 mole. That is F. Okay. Yeah. And EMF of the cell. Right. We will split this condition into 3 categories. Just now we have seen in the last slide also. Delta G is equal to minus N F E cell. E cell, if it is positive, delta G is negative, the cell will work. Spontaneous. Just now we have seen in previous slide also. And if suppose the EMF of a cell is negative, E cell is negative, delta G is positive, the cell will not work. It is going to be non-spontaneous. Such reactions are used in electrolytic cell. Okay. In electrochemical cell, the Gibbs free energy change should be negative and EMF should be positive. That you should remember. Suppose if EMF of a cell comes out to be 0, E naught cannot be 0 because E naught is fixed. That is determined by taking the difference of cathode and anode. Is it clear? Aisha, Marwa, Ibrahim.
Yes.
So,
Yes, sir.
so E naught is fixed. That is only for 1 molar concentration. But we know every time the concentration is not 1 molar, pressure is not 1 molar. So E cell can have any value, positive value. If the E cell is positive, means cell is going to work. E cell is negative, that cell will not work. It is dead now. E cell is 0, that is also dead cell. Okay, the Gibbs free energy now it is not decreasing. Okay, it has become 0. Means now the reaction will not progress anymore in forward direction, and this is the condition of equilibrium. Equilibrium for the reaction mean the reaction is happening, but happening in both the directions, so no net reaction is happening. So is this clear to all of you? This is the first and the foremost thing which all of you should remember. Is it clear or not? So let's do one numerical. Just a second. So suppose if any reaction is given and you will be asked to calculate its Gibbs free energy change. Okay, you can calculate it very easily. Whatever the EMF is given to you, that you can use to calculate. So this is let me give you one question. This is the reaction to Ag plus Cu, giving you copper 2 plus and 2 Ag. This is the chemical reaction. Got it? Standard EMF is found to be found to be E naught equal to for the cell reaction is plus 0.48. What is the value of standard? Suppose, be very careful. If the EMF is given, you are going to find the delta G. If the standard EMF is given, E naught is given, you are going to find the standard Gibbs free energy change. Okay, you are going to find the delta G. What is the value of delta G naught? What is the formula? Yes, Ibrahim, can you help me out? How to do this problem? Aisha, can you help me out? What is the formula for delta G naught? Marwa, what is the formula for delta
Sir,
G
will
naught? Yeah.
will the delta G be negative? Or
Delta G naught equal to, first we should write a formula. Okay, yes, it will be negative. Yes. Minus NF E naught cell. This is delta G naught standard. So I should write E naught cell. If they give E, so you should write delta G equal to minus NF. Okay. And this EMF is positive. So this is going to be negative. So what is this value? That is being asked. How you are going to calculate what you are going to put here to get the answer of delta standard Gibbs energy change. So what is the value of N? There are two positive ions. N is 2. Okay, two positive ions. 2 electrons are taken. Yes, exactly. Okay, our copper has lost 2 electrons. You can see it has become 2 plus. N is 2. What is the value of F? 9, 6. F is the charge. So 2 moles of electrons are transferred, and total charge which is being transferred into 2 into F, because F is the charge of 1 mole of electrons. Okay, 96500 coulombs is the charge for 1 mole. And E naught cell is already given, plus 0.48. So delta G naught is minus twice of 96500 into 0.48. Got it? This is joule, right? And suppose this value is coming out to be around minus 88780 joules. Normally, don't forget it to mention it in kilojoule. 88.78 or 89 if I round it off. Kilojoule or kilojoule per mole of reactions. Is it clear? EMF is positive. Either you can use EMF to say that the reaction will happen, or the delta G is negative, so that also predict that the reaction should happen. Any doubts on this? All of you, tell me. Marwa, is it clear? Aisha, Ibrahim?
No, sir.
Yes, sir.
Okay, so I hope this is clear to all of you. Now, suppose the reaction initially, suppose you have taken only reactants. The reaction will move forward, and as it moves forward, the concentration of the reactant is decreasing, the product is increasing. A point is attained when the concentration of the product is sufficient, products are sufficiently formed, and the product and reactant can again start reacting backward. So that is the point when the reaction stops or the cell stops. That is a point when the reaction attains equilibrium. Equilibrium means it can happen. It is happening in forward and it is happening in the backward direction also with the same speed. So the reaction is not happening net. There is no net reaction equilibrium. At equilibrium, the delta G is 0. Is it clear? Equilibrium constant can be found out by using delta G naught. RT ln K. Ln is log to the base E. So I will simplify it, minus 2.303. R is a gas constant, T is the temperature in Kelvin, log of equilibrium constant. So standard Gibbs free energy change can be used to calculate the equilibrium constant of a reaction. Equilibrium constant has the same expression as the reaction quotient. It has the same expression as the reaction quotient. And Exactly, but the concentrations are at equilibrium. Suppose, let's say, if I give you this reaction, let's write the Daniel cell, which is the most famous. So zinc get oxidized at the anode and copper 2 plus get reduced at the cathode.
Sir, I didn't understand log constant.
Yes, I'm coming to that. Don't worry. Okay. So initially, if you start with reactants only, the reaction will move forward. More and more products are forming. But as the products are forming, the products has also the tendency to convert back to reactant. So initially the cell will work. After some time, forward reaction is also happening, and because you have sufficient amount of copper and zinc 2 plus, the reaction will happen in backward direction also. That is the point which is known as equilibrium. And if the equilibrium is attained, the reaction doesn't move in any direction. It stops. Means it is happening, but it is happening in both the directions with equal speed. So no net result is being observed. What is the expression for the equilibrium constant? Aisha, Marwa, can you tell me? Equilibrium constant is the concentration of the products, each raised to the power its stoichiometric coefficient of the balanced chemical equation. The coefficient is 1 everywhere in this. Got it. So zinc 2 plus concentration raised to the power 1. Concentration of products you are going to write. Copper, solid. This is copper, this is zinc. Divided by the concentration of reactants. Zinc is rod in the form of a rod, so solid. And on the reactant side, you have copper ions raised to the power 1. No need to mention 1. For solids, pure solids, copper rod and zinc rod, their concentration doesn't change because you can change only the concentration of ions. So you remove them from the equilibrium constant. So K is zinc 2 plus. In the question, they will give you the concentration. Got it? You can put the value of the concentrations, simplify it. You will get the value of equilibrium constant. Is it clear? If you get the value of the equilibrium constant, take the logarithm of that value. That value, if it is just a simple value, you can yourself get it. Like suppose I told you in the last class, log 2 is 0.3. Remember it. Log 4 is 0.6. Okay, twice of this. Okay, log 4 is 2 to the power 2. Log 3 is 0.4771. Log 10 is 1. If there is a non-standard value, they will give it in the question. Log 100 is 10 to the power 2. So it is 2. Log of 1000 is 10 to the power 3. 10 with 3 zeros. Okay. Okay. So mean total there are 3 zeros. 10 on with 1. So 10 to the power 3. So it will be 3. So for multiples of 10, the value of log will be equal to the number of zeros which are there after the 1. Okay. For other non-standard values, log 2, log 4, log 3, you can remember. Any other value they will provide in the question. Got it? So K you can calculate from the expression, and R is constant, gas constant, 8.314 joule per Kelvin per mole. Remember this value. T is the temperature in Kelvin. Normally it is 298 Kelvin. Is it clear or not? Let's do one question, and that can help us to understand the problem in a better way. Let me give you one question. So just tell me the formula, because I know you can put the values and do it. You can tell me the formula which is going to be used. Find the standard Gibbs free energy change. So which formula are we going to use, Ibrahim?
So announce the equation.
No, I'm not asking the EMF of the cell. Am I asking that
Oh, okay. Gibbs free.
at some other
Okay.
concentration? No.
Okay.
This
So we'll
is
use the delta G.
standard Gibbs free energy change. What I'm asking? Delta G naught. Okay. Equal to, what is the formula?
Negative
Negative of N
NF E cell.
E cell.
E
And
naught.
if it is not, E naught. Yes. N is N you can see is 2. Okay. N is 2 because plus 3 is getting 2 electrons and changing to 2 plus 2 ions, or I minus 2 I minus losing 2 electron to become I2. So minus 2 into 96.00 into 0.24. Okay, this is how you are going to calculate. Okay, it is in joule. Is it clear? Suppose if I ask you to calculate the equilibrium constant of the reaction. So equilibrium constant is the ratio of the concentrations of products and reactants at equilibrium. That is represented by K. Okay. And that is the ratio of concentration of the products. Okay, this is Fe2 plus. The concentration is raised to the power its stoichiometric coefficient 2. I2 concentration of I2 aqueous raised to the power 1 because I2 doesn't have any number here, means it is 1, divided by concentration of reactants Fe3 plus raised to the power 2 I minus to the power 2. The coefficient is 2. So equilibrium constant is the ratio of concentration of products to that of the reactants. That is K. Okay. So if the concentrations are given at equilibrium, you can find the value of the K directly. Sometimes they do that also. If it is not given, if you are asked to calculate the K with the help of standard EMF of the cell, so you are going to write the relationship. What was the relationship? Can you tell me? Between the EMF of the cell and the equilibrium constant. So this we have already written NF E0 cell, right? And this is equal to minus 2.303. R is the gas constant. This is a constant into temperature into log of K. Okay. So log of K is going to be delta G naught minus delta G naught by 2.303 RT. R is a gas constant. Remember its value. R is temperature is 298. Normally it is 298. So log of K you can calculate, or you can calculate by, if E naught is given, delta G naught you can find out. You will put minus NF E naught. Minus minus will get cancelled. Two 2.303 into R into T equal to log K. You will put these values. Let me make it very simple for you. We have seen in the Nernst equation 2.303 R into T by F equal to 0.0591. Remember this at 298 Kelvin. So you don't have to put these values again and again. You don't have to put these values, just remember it 0.05, or you can take it 0.06. So this is E0 cell upon 2.303 RT by F n E0 cell by 0.059. And you can put from the equation E0, you can get the value of log K. Okay, now how you will simplify? This is the formula. Whatever value you get, this is from a mathematical portion. So K will be equal to 10 to the power value. So this will be the answer. 10 to the power value, whatever the log K is there. So that is The definition of log is, it is the number by which the base must be raised in order to get a number. Okay, but that is mathematical part. They will give you the value, or they will give you anti-log. Anti-log means you remove anti-log. If you take anti-log on both the sides, they will give you the value of, in the question they will provide. Anti-log value they will give. So anti-log means 10 to the power of that value is anti-log. So they will be mentioned in the question, given in the question, because earlier during my time, I remember we used to get the tables, logarithm tables, but now that is not there, I think. So you can remember the values of the log 2, log 3, okay? And they will provide you the values also in the question if they are not the standard values. So don't worry about it, okay? So in this portion, Aisha, Marwa, Ibrahim, what need to be explained? Just tell me this. This is the formula. You can just, this portion is very, very important. But very simple if you can remember the formula. If you are given this portion is very useful, especially this equation. If you write, you can calculate anything. Okay. Is it clear?
Sir, log K will have different values, right? Like for different questions.
It depends upon the value of K. It depends upon the value of K. Log K can have different values, yes. Okay. Clear? This is how, so first you are going to write this formula. Is it clear?
Yes, sir.
And you can calculate the value of log K. And what is the value of K? If log K you get, they will give you the anti-log value. Take the anti-log. Okay. Suppose log K is X. So the K is equal to 10 to the power X. Either you will write it like this, or K equal to anti-log of X. 10 to the power X or anti-log of X is one and the same thing. So either they will give you the value of 10 to the power in the question they will mention, or they will give you the value of anti-log. Anti-log of X equal to 10 to the power X. They will mention it in the question. If X is 2, then it no need to mention, because 10 to the power 2 is 100. Clear? So this again is a very simple question. Though it is from IIT, but it is a subjective question, can be asked in your CBSE examination. So these are the two equations. One is anode, one is cathode. Higher one is cathode, and the lower SRP is anode. Is that clear? You can find
Yes, sir.
the EMF of the cell. E cathode minus E anode. Be careful about the charges. This is the EMF of the cell, and you can find the delta G for the whole process. N is 2, F is 96500, and EMF of the cell, you can, whatever the value which you are getting, put it here. You will get your answer. This is very simple question. I hope all of you can do this. Any doubts in this? Any doubts, Ibrahim, Aisha, Marwa?
Sir.
No, sir.
Okay. So this is just a simple question. Let's move to the next question.
So
Yeah.
the number of electrons in this question is 4, right? Because
No, actually, yeah, 4 means two. Actually, how you are going to make a cell equation? 2 are released from the anode and 2 goes up to cathode. So you no need to count them twice. The number of electron transferred between anode and cathode. Is it clear? It is 2, not 4. Because how you are going to make the cell equation? Cell equation is made by subtracting the equation of cathode, but first cross multiply the equations with suitable whole numbers, but don't multiply the E naught value because they are fixed. But cross multiply with the equations with whole number to make the electrons same. Electrons are already same in this, so I will write the equation for the cathode minus anode. This is the cathode, so this is the receiving electrons and this is anode. So this is giving this 2 electrons and those 2 electrons are going towards the cathode and changing the oxygen to water. Okay. And when you subtract them, the electrons should get cancelled completely. So E cathode minus E anode, there is a transfer of 2 electrons taking place. But the 2 electrons appear twice because they were released from the anode and got up to cathode. But that doesn't mean they will become 4. Because you have to mention them 2 times. Okay. Because they are being released and being accepted. But that doesn't mean that 4 are accepted. Only 2 are accepted and 2 are released. Right? So whatever are released from the anode, they will go to the cathode. Is it clear? Any doubts, Aisha?
yes, sir.
So we have now the value of equilibrium constant being asked. So let's try to do this. And let's try to understand that what value do we get if we simplify the log and all, right? So what formula are we writing, Ibrahim? How we are going to do this? Aisha, how we are going to do this? Marwa, how we are
So
going to do this? Yeah, tell me.
we'll use Gibbs free energy
Yes,
because N is given and
delta
standard as cell potential.
involving 2 electron chain. They have already given the value of yeah, Ibrahim, let me check it. Standard EMF of the cell is found to be this much. Okay. So E naught is given. Delta G naught equal to minus NF E naught equal to minus 2.303 R into T into log of K. Okay, and they are asking us the equilibrium constant at 298 Kelvin. So Marwa, log of equilibrium constant, but directly we are not going to get the K. We are first going to work with log K. Log K, I will segregate all these terms on this side. I will remove the minus NFE naught by 2.303 RT. That is the value of log K. Is everybody agreeing with this? Write the formula very clearly in your board examination. Okay, I always, because there are marks for the formula, then put the values. Okay, so even if you are unable to get the final answer, you will get almost most of the marks, right? And I told you, remember that from the next equation 2.303. What is the value of 2.303? RT by F. What is the value of this? That we have seen in next equation also, Ibrahim. 0.0
0.059.
yeah, 591 or 0.06 also we take. Okay, so this I will bring it down. So log K is equal to N is 2. We have given 2 electrons transfer. And E naught is 0.295. Okay.
Sir,
Yeah.
can we use 0.06?
Yes, you can use 0.06. That makes the life easy, right? And
Yes,
the calculation very easy. Many places it is used as 0.06 only. Okay. And this is the E naught and 0.0591. This is the value of log K. Okay. So I'm going to get if 0.295 divided by 0. If I take it 0.06, then I will cancel this 2 and 0.03. It will become 0.03. And it will become 29.5 divided by 3. 3 nines are 27 to the 25. 9.5. So 20. Okay, somewhere around this 9.8. Is it clear? So you are going to do this much calculation of log K. Let me get the exact value. 0.295 into 2 divided by, now this value is actually working with, this is exactly you are getting 0.059. If you try to multiply 0.05, 0.59 you are getting. And this you are getting 0.059. Sometimes the value is in the multiple of 59, so don't use 0.6 there. Okay. That because if it is getting directly cancelled, you can use it like this. Is that clear, brother? So this is coming out to be 10. This is also, if you round it off, it is going to come out to be 10. 9.8 is somewhere, 9.89 it is going to be 10. So log K is 10. And K is, so whatever the base is there, base should be raised to the power given number. 10 is the base and the value of log is 10. And that will give the value of K. This is the definition. For example, if you have log 4, okay, to the base 2, okay, equal to x. So 2 to the power x equal to 4. So base, this is the base, this is the power. Base must be raised to the power. 2 must be raised to the power x, and that should be equal to the number. So base must be raised to the power 10 to get the number. Okay. This is the answer. Clear? Any doubts in this? Just let me know. Log K. Let me give you one more example. Suppose log K, you are getting 3. So what should be the value of K? Base is 10. The base of logarithm is 10. There is a number and there is a base. If the base is not written, it is 10. It is obvious. So you get the value of that particular number by putting the answer, whatever the answer is given of the value of the log is given as a power of the base 10 to the power 3. 10 to the power 3 equal to K. So the answer is 1000. Or in the question, they will give you NT log 3 equal to 1000. So if you take NT log, this will get cancelled. This is NT log 3 is 1000. They will give you in the question itself, they will give you the values. So no need to worry. Suppose if you get a different value of log and if you don't remember the value, you don't have to worry, because if you are getting a different value, they will give you the value of that K. Logarithm value they will give, or NT log value. NT log is used when you remove the K, when you remove the log. So log K is something, K is NT log of something. They will give you the NT log of this is this much, so you put that value in there and you will get the answer. Marwa, is it clear? Aisha, is it clear?
Yes, sir.
Is this clear? Any doubts in this?
No, sir.
So actually we didn't do logs in school. What is anti-log?
Anti-log is 10 to the power something. Suppose either they will give you 10 to the power 3. Okay. How much is it? 1000. Okay. Or they will give you anti-log 3. That is 1000. Anti-log means 10 to the power. Anti-log of something is 10 to the power something. So log, let's say, I will take one more example. Is 4. So what should be the value of K? If anti-log is not given, you should take the base as
10 to
10.
the power 4.
Yes. Okay. K is equal to 10 to the power. Or got it? This is 10,000 is the answer. Or they will give you like this. So if they give it in the question itself, they will give. And because you are getting log K equal to 4, you will write one statement. If they give you, provide this value in the question, they will be giving you. Okay, if it is not a standard value, they will be providing it to you. So write it like this in your school examination. Taking anti-log on both the sides. So if I take anti-log as the name indicates, nt to logarithm. Okay, means it will cancel log. Got it? Taking nt log on both the sides. So nt log of log is that will get cancelled. Okay. And you are left with nt log of 4. Nt log of 4 they will provide, or any other number if it is not a standard number, they will give it to you in the question. Nt log of 4 they will give you as 10,000. You will write the answer as 10,000. Got it? Either you will follow this. If they have given you the value of nt log, do it in this way. Aisha, is it clear?
Yes, sir.
Okay, they will provide you the value in the question. Okay? So don't worry about it. Right. Next is electrolysis. Now we are moving to the electrolytic cell. As I told you, there are certain chemical reactions which do not happen on their own. Non-spontaneous chemical reactions. Their gift free energy changes positive, and their EMF of the cell is negative. Such reaction cannot happen, cannot progress on their own. Now, there are many reactions which do not occur on their own. They are non-spontaneous, they are positive gift free energy change. And they have EMF, negative EMF. Cathode is lower, so current flows from cathode to anode. So cathode should be higher. It is just like a water level. Water can flow from higher level to lower level. So current can flow from higher voltage to lower voltage. If the cathode is higher and anode is lower, current can flow, EMF is positive. If the cathode is lower, EMF is negative. Because EMF of a cell is cathode minus anode. And the cell is not going to work. Got it? Is it clear? But this is known as electrolytic cell. If the reaction cannot happen on its own, and the most famous reaction is none other than a very common reaction which you may have studied in your junior classes. It is this reaction. Water being changing to hydrogen and oxygen. Can this happen on its own? Can we see it happening in our daily life? The water is changing to hydrogen and oxygen. Does that happen?
Yes,
Marwa,
sir.
does that happen? Or normally, at suppose if you have a glass of water and the hydrogen is coming out, oxygen is coming out, do we see it?
No, sir.
Hydrogen, if we don't see it, hydrogen is highly inflammable gas. Okay, this is a non-spontaneous reaction. It cannot happen. Its gift free energy change is positive and EMF is negative. It cannot happen. On its own, it cannot happen. But on its own, it cannot happen, but we can do it. Okay, suppose if there is a block of wood, if there is a block, can it go up? Can it move up on its own? Can it go up on its own? No, it cannot
No,
go.
sir.
So how? So that's because its potential energy is increasing. Same is the case here also. Gift free energy is increasing as it is just like the energy it is increasing. So this cannot proceed on its own. So what is the method to move this block up? We need to push continuously. We need to put some work. Is it clear?
Yes, sir.
So these are the non-spontaneous reaction. They can progress. If external voltage is applied. This block can move off if I push continuously. Similarly, this reaction can happen if I connect it to some anode and cathode, and if I apply voltage, so electrical energy is consumed. And this is just the reverse of the electrochemical cell, where the reactions were have a tendency to happen on their own. They were generating electric current because their EMF was positive and we were getting the positive voltage from them. But such reactions where they cannot happen on their own, we need to put continuously some external work in order to do such reaction. Okay. And these are non-spontaneous reactions. Got it? Delta G is positive. Electrical energy is consumed. You need to put some energy. Okay. And the compound changes its chemical composition. New chemicals are formed in this. So this is electrolytic cell. Electrical energy causes non-spontaneous reaction to occur, and the process is known as electrolysis. Electrolysis, as the name indicates, electrolysis. Lysis means to break. You are passing electric current, you are putting electric current, and you are breaking a compound to some new components. For example, if you take NaCl liquid, does NaCl change to sodium and chlorine? It never happens. We don't see the sodium chloride is a common salt which we have in our homes. Does it change to sodium and chlorine gas? Chlorine gas is very poisonous. Sodium is very reactive. We don't see it happening. Why we don't see it happening on our in our kitchen where we use NaCl? We use it in our food. The answer is quite simple. The EMF is, you can see the value of EMF. Negative EMF. Delta G is minus NF E naught. That is going to be positive. So it is a non-spontaneous reaction. Is this clear? But how can you let it happen? We can let it happen if we put some external voltage. An external voltage greater than 4 volts. It should be greater than 4 volts, then only this reaction will happen. Are you getting my point? Aisha, Marwa, are you getting my point? Ibrahim?
Yes, sir.
Okay. So non-spontaneous reactions, negative EMF, and they can be carried out by putting external voltage, external electrical energy, but be careful that external voltage which you are applying on this reaction should be greater than 4 volts or plus 4 volt. Then only this reaction can happen and you can make sodium and chlorine gas. This is electrolysis reaction. Non-spontaneous reactions. Look how this has happened. So passing of electric current through the molten, and this is molten NaCl, you put anode, cathode. Okay. The voltage you are applying is more than 4 volts. Is it clear? Then only it will happen. So this is positive. The sign is opposite. At anode, oxidation is happening. Okay. But anode, there in the zinc electrode, the oxidation was happening on its own. The zinc was losing electron on its own, so there the anode was negative. Here the anode is positive. That is the difference, because it is connected to positive electron, positive terminal of the cell. Because this reaction is not happening on its own, and then you have a cathode which is negative. The battery must supply at least 4 volt or more than 4 volt for this reaction to happen. Is it clear? Now on the next turn, so this is basic idea of electrolysis. We are going to discuss the Faraday's law of electricity, which are very